here we go, finishing up yesterday's notes. We stopped at number 5 yesterday. And again, I just was going to reiterate now that I'm recording. I know I said this already to y'all. We talked about our 3-step process. We isolate the absolute value expression. We are going to clear those absolute value bars by setting up 2 equations. We're going to set the inside of the absolute, what's inside the absolute value bars is going to get set equal to a positive number that we're equal to once it's isolated, and the opposite, the negative version of that number. Okay, and I showed you graphically in Desmos what it looks like when you isolate your absolute value expression. If you are left equal to a positive number, you're going to have 2 solutions. Okay, when you isolate it, if it's set equal to a 0, there's only going to be 1 solution. And if when you isolate that absolute value expression, it is set equal to a negative, there will be no solution. And graphically, that's what those look like. Okay, never crossing, only intersecting at the vertex or crossing anywhere else across that V shape. Okay, and then we got through example 5. Okay, so we're on 6. Now, 5 and 6 are very similar. What is the only difference in 5 and 6 when you look at those original equations? Right, that 1/4 is inside on number 5. It's inside the absolute value bars. And here on number 6, it's outside the absolute value bars. So remember, step 1 is to isolate the absolute value expression, which over here, it was already isolated. All of that is in the absolute value bars, right? So it was isolated. There was nothing outside of it that I needed to move to the other side. But the way that it's set up here, when I look at the absolute value expression, that 1/4 is outside of it. So I need to move that 1/4 first before I set up my 2 equations. So instead of, we said over here, instead of dividing by 1/4 when we had to move it, we multiplied by 4. You can multiply by the reciprocal of a fraction instead of dividing by a fraction. Okay, so I'm going to do the same thing. I'm just doing it much earlier in this problem. Oops, I want pen, not highlighter. So I'm going to multiply by 4. What I do to one side, I do to the other. So here that 4 and 1/4 will reduce. And now I've isolated my absolute value expression. And that would be 80. So far, so good? Now that I've isolated it, that was step 1. Step 2 is to set up your 2 equations. So I'm going to take what's inside, that's the x minus 10, and I'm going to set it equal to 80. Okay, or it could be equal to negative 80. Okay, I knew right away once I isolated that and I saw that it was equal to 80, I knew I was going to have 2 solutions because it's equal to a positive number. Now I solve each of those equations. So to isolate x, I'm going to move this 10 by addition. What I do to one side, I do to the other. And I like to work both at the same time. I'm going to just add 10 on both of these. If you prefer to work one of these and then come back and work the other, that's fine too. So I get 90 or negative 80 plus 10 would be negative 70. I told you you could check your answers by actually inputting these into the equation up here. So if I did 90 minus 10, I'd have 80. And then a fourth, or excuse me, the absolute value of 80 is 80. And then a fourth of 80 is 20. So that one checks out, and then you could check the other. Okay, but I'm just going to reiterate to you also, once you've isolated the absolute value expression, we've got the absolute value of x minus 10 equals 80. You could come here and you can do the absolute value of x minus 10 as one equation, and then y equals 80 as the second equation. and we can visually see, well, 80 is way down there, so I got to zoom out to see it. Or yeah, there it is. So I can visually see where those two intersect at -70 and at +90. Does that make sense? Okay, so you can check it in Desmos. You can check it by plugging it back into the equation. Both of those work. All right, so let's look at these last two. On number 7, is there anything I need to do for step 1 to isolate the absolute value expression here? It's already by itself over here on the left side, isn't it? Nothing outside of it being multiplied or divided or added or subtracted. It's already by itself on one side of the equation. So we are ready to set up our two equations. I'm going to say x plus 4 equals 3. Or x plus 4 could equal -3. I know there's two solutions because this is a positive number. Now I'm ready to solve. What am I going to do to solve for x? How do I get rid of +4? Good, -4. So I get -1 or -7. And you can check those in Desmos, or you can check them by plugging them in and working it out. All right, number 8 is a little more complicated. I've got my absolute value expression. So is there anything I need to move for step 1 to isolate this? Is there anything outside the absolute value bars on this side of the equation? Yeah, that 4/3. I definitely have to get rid of 4/3. There is no sign in between 4/3 and the absolute value bar, right? So that is understood to be multiplication. So the opposite is divide. So I could divide by 4/3, or just like I did up here with 1/4 when I had to get rid of it, I could multiply by the reciprocal. Reciprocal, again, means flip the fraction. So what is the reciprocal of 4/3? So instead of dividing by a fraction, I think it's easier to multiply by the reciprocal, because you can see then the 4s will reduce and the 3s will reduce, and that's gone. What you do to one side, you have to do to the other. So we have to multiply by 3/4 on the right side as well. Well, 8 times 3 is 24. 24 divided by 4 is 6. So this comes out to 6. Or some of you may prefer to reduce first and say 8 divided by 4 is 2, and 2 times 3 is 6. Oh, yeah. So either way, you get 6. So we've isolated our variable, or not our variable, excuse me, isolated our absolute value expression and got that it's equal to 6. So how many solutions am I going to have here? I've isolated and it's equal to a positive number, so I know how many solutions? 2. So I'm going to go ahead and split this up. 2x plus 6 is equal to +6, or 2x plus 6 would be equal to -6. Okay. Now solve. Last step. What am I going to do to solve for x? What do I need to move first? I need to move the +6, so I'm going to do that by subtracting. So we do opposite operation. You do to one side, you do to the other. Okay. And again, I've been working the two equations at the same time. I'll show this one. I'm just going to work one at a time, and then I'll go work the other, and you can decide which you prefer. So 6 minus 6 is 0. Then I need to get rid of that times 2 by dividing by 2. I get 0. Or Let's see what we get over here. So this should be the same steps. We're going to subtract 6. Divide by 2. And I get -6. You feeling okay about those? That 3-step process. Okay, so the paper, those are, you keep those with your notes. You don't have to do anything with those or turn those in anywhere. Okay, the paper that you picked up when you came in, this one. All right, so I've got those 3 steps written out here in print for you. Okay, they match what we wrote yesterday in our notes. We isolate the absolute value expression, then we create 2 cases or 2 equations. We set the inside equal to both the positive and negative value of whatever that number is on the other side. Now, if you want to make a note on here, you don't have to do step 2 if that number on the opposite side is negative, right? Because if when you isolate that expression and it's equal to a negative, you know what? There's no solution, okay? So most often, yes, we're going to create 2 equations and then solve both equations. But there's always that possibility that if it's set equal to a negative, there's no solution. Or if it's set equal to 0, there's only going to be one solution. We're only going to have to create one case and solve it because it's going to be equal to 0. And 0 doesn't have a positive or a negative, so it doesn't split into 2, right? All right. So there are 18 problems here. I'm going to do 3 of them with you. Okay, I'm going to let y'all glance through these. These look more complex than the ones we did yesterday. Okay, they are. There's some different types, different steps, more steps. Okay, so they're a little more complex than what we started with yesterday. You look through them and y'all can just volunteer what number you would like me to work with y'all. Okay, and then the remainder of what's left, there will be 15 left. You can work on your own if you choose, but you may work with a partner or up to a group of 3, no more than 3 people together, okay? And you're going to work the rest of this with your group or partners. And what I am suggesting that y'all do or requesting that y'all do is, let's say you and your partner split up. You could split and say, I'll do evens, you do odds. Or you could say, just start with 1 and 2 and be like, okay, I'll do 1, you do 2. And y'all just do those 2. Okay. And then you're going to switch and then you're going to check each other's work. So it's very important you are showing your work on these so that your partner or your group member can understand your process and see what you did and find any mistakes if there are any. Okay, and then y'all check each other's, you fix mistakes if you find mistakes, or you confirm and say, yeah, that's right, I agree. Okay, and then you move on. You say, okay, I'll do 4 this time, you do 3, and then you work them, and then you trade papers and check them again. Does this make sense? Now, I would suggest doing that, doing 1 problem, trading and checking, and then going to the next and trading and checking, and then going to the next and trading and checking. If you would prefer, and y'all split up all of your problems at the beginning and do all of your work for like all 7 or however many you're doing, and then trade at the end and check them all. I mean, I'm not going to say you can't do it that way, but I still would recommend you do check 1 at a time. Do 1, check 1, do 1, check 1. Okay. You are going to submit the answers for all 18. Including the 3 I do with you. So essentially, I'm giving you 3 of your answers, okay? But you have to show the work so your partner can confirm if it's correct. If y'all don't actually check each other's work, you may be submitting a lot of wrong answers. So your grade is dependent on the work you do and the work your partner does. So that's why I'm having y'all check each other and fix mistakes, because then you're going to go on Canvas and you're going to submit the answers, okay? When you're on Canvas submitting your answers, it's a fill in the blank, it's typing. So like number 1 will show up and it'll say X equals blank and blank. It matters what order you type the 2 answers in, because I can't set it to accept it either way. I haven't figured that out yet. So I'm going to have it in numerical order, least to greatest. So when you get your 2 solutions and you go to fill in those blanks, you're going to type in the lowest number first and then the highest number. So make sure you pay attention to the order, numerical order, least to greatest, when you're typing in your answers on Canvas. Okay. Now, if there is no solution, which I'll tell you there's at least one on here that's no solution, instead of typing, it's going to say X equals blank. And if there's only one blank, that's either indicating to you that there's only one answer or there's no answers. And if it's no solution, you'll type in the word no solution. If there are 2 blanks in Canvas, that should clue you in that you should have 2 answers. It's not no solution and it's not one solution. There should be 2 answers if there are 2 blanks. Okay, so that's a hint for you to kind of be checking yourself when you go to type your answers in. If there is only 1 blank, you should either be typing no solution or typing in the 1 answer. Okay, does that make sense to everybody? All right. Does anybody have one that they request that is one that I do with y'all?
Once you get both
Yes. Yeah, when you get your 2 solutions, good question. Remember, they do not have to, let me go back to some of the examples we did over here. When we started this, notice these 3 and 4, we got opposite numbers. We got 6 and -6, 5 and -5. Those are opposites of each other. Your answers can be opposites of each other. They do not have to be. So notice then we got -4, -8. Those aren't opposites of each other, okay? Or 3 and -8. And notice this one, we had 2 negative answers. This one, we had 1 positive and 1 negative. So there's not some set way that your answers should be. Like they have to be opposites of each other. They both have to be positive, or they both have to be negative, or they're going to have 1 positive and 1 negative. Okay, that's not necessarily true. Okay, so there's here, I got 2 negatives. That's okay. That's correct. Okay, here I got a 0 and a negative. That's okay. It's correct. Check your answers. Once y'all check each other's work, if you want to take the extra time and go double check in Desmos before y'all submit your answers, that would not be a bad idea. Remember, when you're going in Desmos, once you isolate, it would be this step right here that you're typing in Desmos. I would type in the absolute value of 2x plus 6, and then I would type in y equals 6 as the second equation, and I would look to see where they intersect. And I would confirm that it's when x is 0 and x is -6. So once y'all do the work and check each other's by looking at the work, then you could go in Desmos and check and confirm before you go to submit on Canvas. I know a lot of our assignments in Canvas before, I've set multiple attempts. I am not setting multiple attempts. Y'all are checking each other's work. That's your multiple attempts. You attempt it, you have your partner check it, and if y'all both agree, I would check in Desmos to double check, because once you submit it in Canvas, that's your answer. Okay, I'm not giving extra attempts on this assignment. Y'all are in charge of checking each other and checking yourselves before making your submission. Good? Okay. All right, back to this one. Did anybody have a request for a specific one that I do with you? Anybody see one that 6? Okay, let's look at number 6. So number 6 definitely looks different than ones we've done before. It has our absolute value expression is over a number. So it's a numerator of a fraction. So this is, again, what we're trying to isolate, this absolute value expression. So that divided by 9 is outside the absolute value bars. So I need to move that to the other side before I set up my equations. How do I get rid of divided by 9? multiply. The opposite of divide is multiply. So I'm going to multiply by 9. And what I do to one side, I do to the other. So I get rid of the 9 over here. It reduces. That's just a 1 now. So I've got the absolute value of 3x plus 12 is equal to what? What's 0 times 9? Still 0. Well, how about that? Is that one of those special cases we talked about when you isolate your absolute value bar and it's equal to a 0? What does that indicate to you? There is only one solution. There is not going to be two solutions to this one. There will only be one solution because that's set equal to 0. I can't split it and set it equal to positive 0 and negative 0. 0 doesn't have a sign. It's not positive or negative. So when I set this up, I'm just going to set it equal to 0. I'm going to drop those absolute value bars and say, okay, 3x plus 12 needs to equal 0. Now I'm going to solve that. How am I going to solve for x? Now it becomes a basic algebra problem. I'm going to minus 12. Good. Move that constant to the other side. And then what? Divide by the 3. Get rid of that coefficient. There it is. Thank you. So I have one solution. Now I could check that graphically, or I could plug it in and check it. Okay. I'm going to leave that to y'all to check before you submit your final answers. Okay. One solution. So when you go to input this on Canvas, it's going to say x equals, and then there's going to be a blank, and you'll just type in your -4. Anybody have another one that looks complicated that they think they might want me to try? Eight? Sure. Let's look at 8 together. Okay, so on number 8, I want to isolate my absolute value expression, which is just absolute value of x over 5. So another fraction, okay, but the fraction is inside the absolute value bars, so it's slightly different. But there's things outside those absolute value bars that we have to move to isolate it. So we've got a -12 and we've got a +8. How are the -12 and the 8 connected to that absolute value expression? What's happening here between the -12 and the absolute value expression? That's multiplication. If it's just up against that absolute value bar, it's being multiplied. Okay, and how is the 8 connected? It's being added. Very good. So what moves first? What do I move to the other side first? No. Think about it, if it was not a fraction or an absolute value. If this was just, if I had -12x plus 8 equals -16, what would I move away from the x first? Yeah, I always move the constant first. Okay, so the constant has to be moved first. So remember, we're working backward. So you're doing their order of operations backward. Normally you think of order of operations, PEMDAS, you think, oh, multiply, divide comes before add, subtract. When you're working backward to solve an equation, you go backward in your order of operation. So it is the addition or subtraction that we're going to do first. So we're going to subtract that 8 to the other side. This is what you do to one side, you do to the other. So I get -24. Equals -12 times the absolute value of x over 5. Okay, now how am I going to get rid of that -12? Yeah, we said that that's being multiplied, so the opposite is to divide. So I'm going to divide by -12. What I do to one side, I do to the other. So a negative divided by a negative is so that's going to be a +2 equals the absolute value of x over 5. All right, great. We've isolated our absolute value. That was step one. That was the goal. Now, how many solutions am I going to have? Can you tell me just based on that step? My absolute value expression is set equal to a positive number. I'm going to have two solutions. Very good. So I take what's inside, so the x over 5, and I set it equal to 2. And I set it equal to -2. Because it can be either one of those. The inside could be 2 or -2. Because when I take the absolute value of either of those, it gives me 2. So now I'm going to solve both of those. How do I get rid of divided by 5? So the opposite is to multiply. So I'm going to multiply the 5 to the other side. I'm going to do that to both equations. So I got x equals 10 or x equals -10. So here's one of the instances where I got opposite answers. But again, that's not going to happen every time. That's not something you should expect. Feel okay about that one? Now, when I go to type my answers in Canvas, let me reiterate this. It's going to say x equals blank and blank. You're filling in the blanks. What number should you write first? In the first blank? The -10. And then the +10 in the second, because least to greatest. Now on your paper, I solved it this way. I got the 10 first and then the -10. But when you're typing them in for it to grade it accurately for the computer to know, I'm putting them in numerical order. So the -10 and then the +10. Make sure you pay attention to how you're typing those in. All right, I'll do one more with y'all. Any requests? No? Okay. Yes, if you can get a fraction, I want you to leave it as a fraction. Don't write it as a decimal. If it is not an integer, leave your answer as a fraction. Reduce the fraction if you can, but just leave it as a fraction because we want the exact answer. I'm sorry? Put the lowest number first. So in that case, -10 was lower than 10. Yes. No requests? Andy, number 4? Okay. All right, let's take a look at number 4, and then y'all will be released to do the rest on your own with your partners or group members. All right, so I need to do step 1. This is not isolated. So how am I going to get rid of that -2 that's being divided? What did we do here to get rid of the divided by 9? We multiplied by 9. So here, to get rid of the divided by -2, we're going to multiply by -2. So I get the absolute value of x minus 10. What's a negative times a negative? Positive. So that is positive 12. So I've isolated it. That's great. And it is set equal to a positive number. So how many solutions should I expect? 2. So I'm going to set x minus 10 equal to 12. And x minus 10 equal to -12. And then I'm going to solve both of those. So I'm going to add the 10 to both sides. And I get x is 22 or x is -2. So when I go to type those in Canvas, which one am I going to put in the first blank? -2, and then I'll put 22 in the second blank. Good? All right. You may move the desks. You can turn them around to face each other. You can pull them closer to be next to each other. Or if you want to, if you're working in a small group and y'all want to sit on the floor or something, that's fine too. So y'all can move around and get started. Again, you're working half of them, your partner's working half of them, and y'all are checking each other's work. Okay. And then I highly recommend you check in Desmos, but I'm not going to force it. It's your grade. Okay. And you're going to submit this on Canvas. We may not get around to having time to submit today. So I'll give y'all a little bit of time at the beginning of class tomorrow to work on this, to get it submitted if you need to. Okay. All right. Y'all get going.